All right, so what you've been doing so far is just kind of playing around with pendulums and thinking about what are the things that could affect the motion, in particular the period. So what factors determine the period of a pendulum? And what I want to know is what have you thought about testing? Not what have you figured out actually determines the period, but what are some of the possibilities? Yeah?
Weight and a straight line those.
Okay, so the weight, and by weight,
So the mass.
yeah, the mass, what we're thinking about is if we build our pendulums such that the string that connects the weighted part to the fulcrum is essentially massless, then really what we're looking at is like all the mass is concentrated at the maximum distance. So we could look at the length of this string between where it's attached to the fulcrum and the mass, and we could look at the size of the mass itself. And I could think of one more that might be worth thinking about.
Starting angle?
Yeah, something about like the height or the starting angle or something like that. So, because if you think about it, it's all going to be related. So if we kind of model our pendulum like this, we have this invisible massless string, it's going to move in this curved path, and we could look at this angle here as sort of being like, well, that's going to matter, or we could look at its height above the ground, something about that's going to matter. We could actually think about it like in terms of the length of this arc, that's going to matter, or even like just sort of a short, like a quick abbreviation as the linear displacement, or even just this horizontal distance. All of those will increase as you pull the mass farther, right? Like the farther up you go, the farther horizontally you're going, the farther along the arc you're going, the farther the linear displacement is going to be, and the farther the angle is going to be. So all of those things are essentially looking at the same thing. And if we're trying to figure out how those things relate to the period of a pendulum, then really what we're looking at is effectively an equation where there's some proportionality, right? Like there's going to be some constant. It's not going to be like t equals and then something about any one of these things. There's going to be some constants involved, but what we really want to know is where do these factors show up in the ratio that we're multiplying that constant by. So for example, we might determine that increasing length increases the period, or maybe increasing mass increases the period, or maybe increasing the angle increases the period, or we might find that those things decrease the period. And it's not going to be both for any one of these variables, obviously, but what we want to know is, does L show up? And if so, is it a direct proportionality, or is it inverse? And same with mass, and same with angle.
From what I've looked at, it seems like the starting height or angle doesn't have much to do.
Did you play around with it? Yeah, so that might be what we find. What I would recommend is that we work together to kind of look at this, and what I would say is, like in a group of 2 or 3 people, just pick one of these things and investigate it really carefully, and then you can kind of work with other students to make sure you're not all looking at the same thing. So like coordinate with other groups. If you talk to 2 groups and one is looking at mass and one is looking at the height, then you pick length. So we'll cover all the bases. Some of you will cover the same thing as another group, so we'll have multiple data points for a couple of these things. But yeah, I think what we want to do is use your data, which will be largely qualitative, to try to figure out which of these parameters actually matters.